Good evening. My name is Dr. Frank Milner. I'm a practicing dentist in St. Paul, Minnesota, and I'd like to welcome you to tonight's webinar, Introduction to Thermally Assisted Composites Using Injection Molding Techniques. I know since the COVID, you probably viewed a lot of webinars. I mean, the distant learning is real, it's here to stay. And I thought I'd give you some provocative material to think about today. And also, wherever you are in the world, I know there's over 1,300 people listening to this webinar, and we'll try to make it relevant, try to make it interesting, and to try to make it didactic so you can take it to your offices. Today, we're talking about something very unusual. We're talking about health and safety. We're talking about new materials, new techniques, new methods. And the materials today are only getting better. I would like to thank my corporate sponsor, Voco America, to make this possible. As you know, I work for many different corporations. I educate in different ways on stage and workshops. And I'd also like to thank Viva Learning for bringing you tonight's webinar. This is my 17th webinar with Viva Learning. So it's been an honor and a privilege to be in front of the audience, you, my peers, my colleagues, to educate you. Let's talk about the objectives tonight. These are new words. Learn the basics of injection molding and thermally liquefied composite. These are warm composites. Now, for disclosure, not all composites have to be warmed, including tonight's composites that we'll be talking about. Thermally liquefied means that you're going to have a composite warmer and you're going to change the viscosity and how you're going to thermally inject into a container of a matrix, a unique matrix. Discover keys to ideal overhang-free margins, something that plagues us all in dentistry. It's plagued me for 43 years to get a mirror finish with complementary flowable and paste composites. Learn the difference between intentional and unintentional excesses. Unintentional excesses are overhangs where biofilm loves to hang out. You know what that does. It's not good. It creates morbidity. And understand why thermally assisted composites are needed in a post-COVID-19 dental practice. Let's start. The Sunshine Act. These are some of the companies I work for, and tonight I am honored to be with Voco America with their products, as well as these other dental manufacturers. For disclosure, Voco America has paid me an honorarium to speak to you tonight. Also, for disclosure, I have not changed any photo. I have not photoshopped. I have not done anything except for cropping my clinical images for you tonight. This is who I am, and this is my integrity. I want to make a special acknowledgement, and that's for a very important colleague and a friend of mine, Dr. David Clark from Tacoma, Washington. This webinar would not be possible without his knowledge, sharing of knowledge at the BioClear Learning Center. Dr. Clark has put his heart and soul into injection molding, thermal liquefied composites, and with an engineering principle. And Dr. Clark is, I consider, my mentor, and I want to say thank you to all his staff at the BioClear Learning Center. And if you do get a chance to do a webinar with Dr. Clark or go to Tacoma, Washington when the time is right, please do so. You're going to learn a lot. Some of the content tonight comes from Dr. Clark, who has shared some of his material with me. So Dr. Clark has really put his heart and soul in trying to change the way we think as dentists. And as you know, if you want to make enemies and try to change something, Woodrow Wilson said this, Dr. Clark is the epitome of trying to change something, and it's difficult at times in the profession of dentistry. Okay, during and after COVID, we have to talk about hope. Hope through education, whether they're webinars, go-to meetings. And one of the greatest values I see as a mentor and as an educator is the ability to see ahead what others can't see yet and help them navigate a course to their destination. I can do this for you tonight. This is what COVID did. We went over the rapids with your patients, with your manufacturers, everybody. We didn't know how how deep the rapids were, how far we would go, are we going to be safe? And now we're coming out of it, and we're thankful we are. If you look at the history of the new norm, well, I wasn't here in 1900, but I took over for the dentists in 1950 that were up above drugstores in their homes, belt-driven handpieces, doing their gold work. And then in 2000, that was probably me with a high-speed handpiece, not electric motor. And then 2020, here we are. This is COVID. This is post-COVID. This is what we look like, the new normal. This is who I am. This is what I look like. I'm a teacher and a mentor. I'm not a salesperson. I educate you tonight. This is my mentoring website and email if you need to get a hold of me. These are where you can find me, and I will take questions that way. This is what I do. I go to foreign countries. I go to Hanoi, Vietnam. I do live patient demonstrations any place in the world, whether it's on aircraft carriers, etc. What do patients and dentists truly want when they come back to the dental office post-COVID? They want to stay safe. They want to stay healthy. They don't want materials and products that are unhealthy, such as maybe bis gamma, free radical monomers, things like this. They want health and safety. They want single appointments. They want no chipping of their materials. They have to come back for adjustments, no gaps, black triangles, or dark margins, things that make them come back to the office again, and they don't feel comfortable doing that. They want it done once. They want it done right. They don't want their teeth ground down. They want reversible, adjustable, repairable seams, not irreversible damage to the tooth. They want healthy, strong, stain-resistant materials. We're going to talk about one of those tonight that fits the criteria of health and safety, fits the criteria of strong, stain-resistant, and with injection molding, they want to postpone irreversible procedures. And finally, the patients want it affordable, and they want it right now. Welcome to the new normal. Here's a fact. Restorative materials are in conflict with the tooth. Instead of grinding down the tooth to fit the materials, i.e. porcelain, what you want to do is have the option of injection molding with a dedicated DuPont Mylar matrices and allow the material to fit around the tooth, like the bottom slide. These are no prep BioClear engineered veneers, composite veneers. The new cornerstones of the new normal are additive guided dentistry. What does that mean? That means we're adding, not subtracting from the tooth structure. We are guiding the material away from very critical areas subgingivally to create an inflammatory process. We're looking for biointegration of the material into the biological part of the gum tissue. Injection molding with thermoviscous, again, you don't have to do this with these materials. This is my preference, to injection mold and have the intentional excess. That means the flash to come out in a place where I can visually see it, and I do not want it underneath the gum tissue. I don't want overhangs. I want pink gum tissue. I don't want purple gum tissue. The infinity margin. This is the tooth restorative interface. Well, you guys kind of think it's a bevel or something like this. The tooth restorative interface is where we want to be in BioClear. This is the heart and soul of the restorative interface. This is where we blend the material out into the enamel and leverage the enamel adhering to the dentin. And we want to put the material around the tooth and not in a hole in the GV black hole and the GV black prep. We don't want to do that. There's no more future in that. It's not the material, it's the method. The new normal is not bonding. The new normal is injection molding with or without thermally assisted composite. Unique matrices with BioClear, DuPont trademark matrices, thinner than a hair. A new technique, monolithic. That means we're going to inject one layer around the tooth, thermoviscous, and it's going to be strong like putting a helmet on a tooth. And then we're going to borrow a term from BioClear. I call it factory finish. Dr. Clark calls it the rockstar polish, no chipping, no stains, none of that. It is a monolithic surface that is enduring in finish and strength. And then we're going to use the engineering principles that Dr. Clark and myself, as a person who worked 8 years in heavy construction through undergrad school, all through dental school, on the job sites, I know all about engineering, and it's time we had that conversation about not science, we're talking about engineers. It's not the size of the preparation, it's the shape of the preparation. We do not want slots from GV Black. We want cable surface margins where we can distribute stress and not have staining and chipping. Once again, the new normal is not bonding. If you look at the comparative study left to right, we're not using flat mylar. That doesn't work. I've had my share of it. We don't want to remove tooth structure. We don't want ledges. We want infinity edges. We don't want staining. We want strength. We don't want layering. We want monolithic injection molding that is engineered to add strength to the tooth. And we want less shades. We want less things that can go wrong with the tooth. What injection molding is, with or without thermal assistance, is shrink wrapping. You know what it's like to take shoes out of a wrapper or bottled water. It's tough. And if you engineer these restorations with injection molding, that's what you're doing, is shrink wrapping the material onto the tooth to make it engineered. So from the manufacturer standpoint, I will challenge everybody and ask them, are you selling materials, or should you be selling techniques and methods, or both? If you're selling product, you need better science. If you combine the engineering principles with better techniques and methods, such as the BioClear modern method, the science only gets better. I'm challenging the manufacturers as well as you, the viewing dentist, tonight. This is bonding. This is could have been my work. This is flashing. This is placed on biofilm, and that doesn't work because what you're doing is trying to paint on rust. So that biofilm has to be blasted off. You can't get it off with hydroxy or phosphoric acid. You have to have a dedicated matrix and a flowable composite to get into there. You can't place it on biofilm. This is suspect. This creates inflammation, morbidity. What you have something like this, which looks all too familiar, into something like this after injection molding with a monolithic surface that does not chip. This is going to go 15 years, no problem. Traditional bonding or injection molding with DuPont Mylar, thermoviscous or not, you can decide tonight. I think you'd want the lower in your mouth. Now, drilling starts the death spiral of the tooth. You're looking at somebody who did GV Black dentistry. We cut big holes in boxes and teeth, and then the stress distribution was shot. The shock absorber didn't work. And if you look at the center tooth right here, the tension ring has been violated. When you open up a joint like this, you release the tension in the spring. This is all engineering, and it gets worse and worse until you try to dig this out and then kill the nerve, and then you wind up fracturing these teeth, and then you get an implant. What we really want to capture tonight, before we get into the materials, is the restabilization of the oral environment. How do we do that from the molecular level to promote health with therapeutic materials, whether they're going to be ionic exchange, whether they're going to be therapeutic varnishes. We want to make the invisible bacteria visible so we can treat it and preserve the oral health and the tooth structure. We want to begin with the end in mind. To create synthetic replicas of teeth, we have to get down to the molecular level and how to restabilize the oral environment with pH strategies, how to create a buffered environment, not an acidic environment. We're talking about bonding, which is adherence, which is adhesion, the epicenter of all dentistry. We're talking about building. We're talking about building with a healthy, safe material. And we're talking about materials that make sense in the new normal. And then we're talking about boosting the oral environment to protect the restoration, to make them endearing or correct the ecosystem of the mouth before you enter in and start your building process with pH strategies. So tonight we talk about adhesion with FuturaBond Universal, and we're going to talk about building with a MyRefusion Extra, which are totally the most biocompatible materials for direct restorative. And then you can also mention glass ionomer. That's a very good dentin substitution. Boosting, protecting the oral environment, restabilizing with either Riemann Pro fluoride varnish that has xylitol and other characteristics. There's a lot of good products on the marketplace today. We come into adhesion, different substrates, different theories, more mineralized, less mineralized. How long do you put it on? How long do you rinse it? Do you keep it wet? Do you keep it dry? Different substrates need different management. We all know this. This is what gets us in trouble, is we mismanage substrates. We dry dentin. We over etch things. You have to be very careful and be a student of adhesion to do anything in the direct restorative world. So if we talk about FuturaBond Universal, and let's not forget other manufacturers, 3M, Shofu, Ivoclar, Clinician's Choice, they're all good. You have to study the chemistry and how to work on different substrates. Do you need a dual cure activator? Is it unidose? Well, it should be unidose today because of the safety and health of the patient. I think the standard that we're looking for today, the gold standard should be, the film thickness should be 5 to 10 microns. And 60 microns won't work because it's too thick. You don't want an adhesion layer that thick. If possible, we would not like a dual cure activator. Not knocking it, there's real good ones out there, but with FuturaBond Universal, you don't need a dual cure activator. With FuturaBond Universal, you don't need refrigeration. You can store it at room temp. Again, there's other very good products out there. You can do your homework and decide what you want. What is the shelf life? Is it marked? Shelf life for FuturaBond Universal is 18 months. Now, as we wrap up the adhesion, I'm a advocate of selective etching, where phosphoric acid is indeed placed on the cavo surface margin, radius bevels, etc. And then I'm an advocate of using a self-etcher on the dentin and not having phosphoric acid on the dentin. You can do what you want. Most of the enamel lifts that I do with BioClear are enamel restorations only. Makes it a lot easier. Let's talk about thermally assisted composites. Again, you don't have to use them. It is my preference to do so. If you look at the composite warmers available today, Voco has one. It's called the CAPS warmer. Here you see a schematic, a photo of it. Let's be fair. You can either go to BioClear and get a heat sink composite warmer. You can go to Adent and get a Calcet composite warmer. Voco has a very good one that has room for the composite gun, anesthetic syringes, and 4 compules. And my preference is at 155 degrees Fahrenheit. There's different adjustments here. You can see, depends on the setting that you want. You can put 4 compules in at once for injection molding. You get about 30 seconds once you load this into your composite gun, is that you have to express the liquefied composite within 30 seconds, because otherwise it's going to cool down and it loses the viscosity changes to it. So this is Voco's CAPS warmer. Now, if we go over the literature, this is not anecdotal. If you look at the benefits of composite warming, of decreasing the cure time, increasing the flow, less micro leakage, less increasing the depth of cure, and polymerization, reduced polymerization, stress, and shrinkage, this is not anecdotal, this is evidence-based, because you can see from these bar graphs, not mine, these are bar graphs, indeed, with the literature, does support the effects of preheating the composite on micro leakage. And this is what I go for, evidence-based science. And you can see here, Carlos Munoz, the surface hardness is better and increases as you heat the composite. Okay, we covered some ground. That was called foundational information. Now we're getting into materials. How do you select the correct composite material? Let's go back to color theories in the world we live in today. In the world we live in, there's 3 million colors in the international standards of color. And what you can see right here is where the human teeth reside. They are up here in the orange yellow quadrant, and there are 1,000 human colors of teeth, of which we as humans can detect 100 colors. And the Vita Classic Shade Guide, as you know, has 15 different colors, or 16, that's 16% not good. But what we do know in the human color range, 80% of the dentin is in the A range, 10% in the B range. This is the human colors up here, and this is the A range right in here. It fits very nicely. So we want to leverage the 80% of the dentin shades you use should be in the A and B range. C's and D's really don't exist. These are different A and B dentin shades with different chroma enamels on top of them to influence that. They are manufactured shades. So we want to leverage our dentin shades into the A range and possibly the B's. The 3 most popular shades are A1, A2, or they could be A2, A3 with a B1. This correlates to the human shades up here in the international standards of color. And so to save inventory and be more profitable, I leverage my A's from the A1 to A6 for geriatrics. I have a B1, and that's probably going to be about it. Now, let's talk about the featured product today. Many good materials I brought forward on these webinars is that we want to talk about them, and we want to talk about AdmiraFusion and AdmiraFusion Extra. These are silicon oxide. These are pure silicate materials. These are a new generation of nano armacers. Organically modified ceramics with the silicon oxide matrix and fillers. They have no classic monomers. This is the world's first, and it is probably one of the most biocompatible materials on the marketplace today. What are they? Well, they're direct restorative. You can use them with any adhesive. You can do any of that, but it has no classic monomers, no bis gamma, no tegma. None of that, no HEMA. This is safe and healthy. There's 50% less shrinkage. I'll talk to you about this, and less shrinkage stress compared to other composites. This is not a sales pitch. This is evidence-based, and I believe this is the next generation of materials today. And it is an aesthetic material as well. When we get into AdmiraFusion Extra, there's only one shade. This is the new launch of a universal material to inherit the color of the environment. Volumetric shrinkage today should be in anywhere from, it could be 1%, maybe up to 1.5%. With AdmiraFusion and AdmiraFusion Extra, we're about 1.25%, which is certainly what I would say a good number today, what you want to shoot for. The surface hardness is due to a lot of different things. It's very high because of the glass fillers are highly filled at 84%. And with the resin content, not with free radical monomers, there's less resin in there. That means there's going to be more filler and it creates a harder surface in the edge strength as well. If you look at Admira Fusion, not our focus product tonight, but I would leverage, if you're using this, I would leverage into the A's. They even have an A5. I'd grab a B1, maybe one opaque A1. And this is really cool. They have a very nice incisal shade as well, as so does the other manufacturers I teach for. This is a new proprietary product called Admira Fusion Flow. This has the same Ormesser technology and chemistry that is a complement to the products itself. They have universal shades. They're 74% filled by weight. And if you look at the compressive strength at 281 megapascals, now you're getting up there. And with the Ormesser technology, there's 50% less shrinkage. As you know, with flowables, that is one of the drawbacks. With the less filled, that you can get shrinkage 5%, 7% sometimes. With this new Ormesser technology of Admira Fusion Flow, these are certainly wonderful products that are safe and healthy as well. The featured product tonight, and where is this coming from? This is Admira Fusion Extra. Pure silicate technology, the Ormesser, organically modified ceramic. The matrix and the fillers are all ceramic with silicon oxide, no free radical monomers. And what makes this really interesting is that, let's talk about another manufacturer. Tokuyama came out with Omnichroma. Well, okay. I work with Tokuyama and I work with Voco, and this is a one shade product, and this will really pick up the environmental shade of the dental structure that you adhere to. And this works. There's only one shade. It's a universal shade. You don't have to heat this. You can. I do, but you don't have to. Okay, you should try the new silicate technology. 50% less shrinkage. It's 84% filled, which is very high. Voco's always been known for high fill content. Grandioso is one that I've worked with before. What is Admira Fusion Extra? Well, it's one shade. Again, it has a low shrinkage of 1.25%. 100% bisphenol free, no classic monomers, Ormesser technology. You can use it with all adhesives, and it goes to a 4 millimeter depth of cure, which is, if you want an injection mold, you certainly can do this, or if you want a bulk fill, you can bulk fill to 4 millimeters, and it becomes aesthetic by inheriting the color and the environment that you adhere it to. Why does this happen? Why is Tokuyama's Omnichroma the same? Well, it's the shape and the size of the particulate matter inside the silicate technology that Admira Fusion Extra has. Because with 20 to 40 nanometers or microns, what you're doing here is you are below the wavelength, a smaller wavelength of light than the ambient light. So the light will go through the spherical particles, not interfering with the distribution of light, the absorption, refraction, dispersion, and it's going to reflect the color of the tooth structure that you're restoring around the tooth, and it is a true chameleon material. It's not the size of the material of the particulate matter, it's the shape of it being a nanoparticulate material. 100% bisphenol free, it's safe and healthy, especially if your patients are looking for that. A high degree of conversion from monomer to polymer, and we're going to talk about this because in the conventional sense, in the molecular structure of the resins, there's 2 points of connectivity that it can connect with a filler material, and that's why you have a high degree of resin that's residual in these. And we'll talk about that. And with the Ormesor technology, each particulate matter of the resin has 100 points of connectivity. So you can see with that kind of connection, you are really going to get a three-dimensional stability of the material, less resin, and there is no free radical monomers in this. This is very biocompatible. When you look at the three-dimensional connectivity of this, you're getting into a very hard material that can be very, very polishable, stain resistant. I've worked with the material. It's a wonderful material to use, and the science does work. If you use engineering principles, you can use this for bulk fill, one shade, very economical to do. It comes in ISO packs. It does a lot of different things. Now, if you look at a conventional degree of conversion, if you have 2 points of connectivity to your resin filler rate, you're going to have a final polymerization of 64 to 68%, which means that you have 32 to 36% free radical monomers going someplace. And with Volco's Admira Fusion and Extra, you get a conversion degree of conversion about 99%. So the prospect of any monomer leaking out is very minimal, plus it doesn't have the free radical monomers. Now, here we go into engineering. This is all about engineering. If you're going to use a 4 millimeter bulk fill, and if you're going to be doing that, leveraging the thickness of material for monolithic strength, I think you have to be a surveyor. And when you survey, you're putting your stake into the ground and finding out where the boundaries and the borders are. And when you are doing bulk filling, I'm going to tell you where to get these measuring sticks. You need to know where 4 millimeters is, otherwise you're going to create a Tootsie Roll in the middle, like a Tootsie Pop. It's going to be soft in the middle. I'm going to give some credibility to Dave Clark and BioClear for their go, no-go probe, for dark triangles, and for a measuring device, surveying where 4 millimeters is, because if you're going there, you better lift up the box and get back to 4 millimeters before you do it. If I was teaching a conventional bulk fill class with class 2 MOD, I would take a perio probe and go to 4 millimeters. And if you are over 4 millimeters, you better raise that foundation up first and do marginal elevation before you start bulk filling and backfilling and being monolithic to get to this. Finishing and polishing. As you know, my work, I'm really artisan based. I'm into finishing and polishing in a logical, sequential way. And I'm into contouring and pre-contouring. Any consummate dentist at BioClear or in the AACD that are accredited members were very keen on the process, and we are very predictable people. After filling the material or restoring with radius bevels in BioClear matrices, or just using traditional ways, the first thing I do is take a scout diamond, a dull barrel-shaped diamond, and go over the surface to verify by integration of the material, no delamination, no interferences, no bubbles, no voids, things that can attract biofilm and stain. This is my scout burr, and it creates the striations that I can go to the next step called disking. And with disking is a setup to finishing and polishing. And if you can't verify your surfaces, class 3s, class 5s, class 2s, in areas that you can't go to polishing and finishing, these are setups to go to the next step. Dr. Clark and myself are advocates after you get down to grade. which is what your final restoration is, then I would, with an air syringe, I would blow air and do another post-cure. Watch out for the heat to guarantee total polymerization, buccal and lingual. Now we'll talk to the factory finish. Now, Dr. Clark calls this the rock star finish. I call it factory finishing. From the industrial side, from the construction side, what we're trying to do is finish the materials to their optimum specifications, to their legitimate shine, to their stain resistance, not chipping, things that can last 8 to 15 years, shy of trauma. And what we'll call this is the Zamboni, because you know on the ice what it does is melt the surface of the ice and creates a unified surface. Okay, you can call it the rock star polish, you can call it the factory finish, you can call it hand finishing, but I call it what is needed as a true restorative engineer. I'm not a cosmetic dentist. I'm an artisan. I'm a guy who knows engineering. I'm a guy who knows how to do it, how to install, how to uninstall, how to do things right, why did it go wrong, how can you re-engineer it, with what products, with what temperature, with what matrices. Demanto is very good from Vocal. It's a one-step polisher, depends on the degree of pressure you put on, how much particulate matter breaks off, and there's many good ones in the marketplace today. Too many to mention right now, but this is a pre-polisher and a high gloss finish, depends on how much hand pressure you put. If you push more pressure, you're going to break down the particulate matter and adjust the surface. If you back off and have less pressure, you're going to get into a high luster. And if you look at the Rockstar polish, whether you're using SS White or Vocal, it's the factory finish, and these happen to be BioClear engineered restorations, monolithic. And you can use Vocal on this, but you have to know how to use it, water spray or no water spray. So if you look at bonding versus re-engineering, injection molding, it should look like Emax with a tooth in it. So these are going to be engineered thermoviscous liquefied with the dedicated DuPont Mylar, and it actually looks like Emax. And this is what you can do with the right materials, with the right modern method to do it. Before we go into the clinical series, let's go what can go wrong and why we come up short of the mark, including me for roughly 35 years, maybe more. Wrong technique, wrong preparation, wrong composite, wrong temperature, wrong finishing, wrong matrix, pretty much GV black stuff. So what we can do is look at the opportunity to invest in health and safety to the patients, into healthy, safe materials with no free radical monomers, with the possibility of thermoviscous injection molding. So we can get away from the GV black slot preparations, which are really tension joints that pull apart and leak. And this is what happens when you don't have radius bevels and transitional restorative interfaces. They leak, they open up, they fail. And if you injection mold with a radius bevel that you leverage the enamel out here, this is where you should be, at the edge of the galaxy of the enamel out here, not confined into slot preparations. This is the infinity edge. We get to the posterior, you can either go patty caking, layer on layer on layer, and every time you do that, you're going to get polymerization shrinkage. You build it up to the occlusal. We've been taught to put nice horizontal central grooves. Engineers call this fracturing, and I don't do this anymore, or do I injection mold all at one layer? We're going to show this now. Wrapping it up, the pillars of modern composite dentistry should be injection molding, monolithic strength at 4 millimeters or less shades, focus on the shapes. The more tooth restorative interfaces, these are called radius bevels, not slots, less shades, and with warm composite. This is where we are today with the modern method and with the new normal for your patients for the predictability with the materials, with healthy, safe materials to introduce stiffness to the tooth. This is a case I did for cuspal onlay using actually the Tucker Gold Prep is where you want to remember for us baby boomers, they're still in the mouth at 50 years. We want to strengthen the cusp, reduce the dentin exposure, and leverage the enamel adhesion. This is a cuspal onlay overlay with a material that could be bulk filled here. I want to talk about root overlays that we can use with Admira Extra. Is that what you want with root overlays is we're not cutting class 5 preps, we're actually going to leverage the radius bevel all the way up to, maybe up to the incisal 1/3 to leverage the enamel on a ratio to missing tooth structure 2-to-1, 3-to-1, and these are PINK prosthetic restorations. As you know, I teach PINK prosthetics from different manufacturers. These are setups for PINK composites or prosthetic gingiva. Lastly, we'll go to the calla lily effect. And from an engineering standpoint, if you create a GV block class 1 with a box, you've created a tension joint. And the strike point is vertical into that, which will pull against your adhesion, and then you get chipping around your adhesion, and that's why these fail. If you have a funneled shape calla lily that goes almost up to the cusp tips, you have a receptacle that can distribute stress and not accumulate stress on the adhesion interface, that you can run that material into a tapered funnel, and that these are enduring for 8 to 15 years. This is a case I did, and you're going to see existing amalgams, and this will be a calla lily, and what you see here are failing amalgams. And when you take these apart, now you'll see the calla lilies go all the way up to the cuspal tips. Right here, these are funnels, and then you do a beveling right here. You don't leave a butt joint, you bevel this to grab some enamel to seal that interface, not have a flat butt joint. Now, with the matrices, you're going to see here, this is all contained, but I'm going to show you a different way to do some business. It's called caulking the window. And if you like, what you can do is put a bumper here, and actually I can seal a flowable interface here and use that to leverage the bulk filling. You can do a marginal elevation in here, but I'll actually light cure this flowable composite, so when I backfill here monolithically, it's going to connect with the flowable and act as a kind of a suspender to stretch a little bit, so you don't pull against your adhesion interface. This is monolithically bulk filled, and this is what Admira Fusion Extra you can do with this. This is done. We'll go to the next tooth. We'll create the bumper here, or the belts and suspenders caulking the window, and then bulk fill this, and this is what it looks like. And this is in true the modern method of the no unintentional excess. These are integrated into the environment of healthy gingiva right here. This is the modern way of doing bulk filling. Now we'll look at couple different things we're going to look at. We're tracking on time, and this is good for Q&A. This is all new language to you. This is the lexicon. When you learn a different language, do you need Rosetta Stone? Well, you might, but you need a new language of engineering. You need a new language of bulk filling. You need a new language of engineering and how engineering drives everything, including science. And if you don't have engineering, you can't figure out what goes wrong and how to fix it. And I do this day in and day out with my old work from the past and with second opinions on failed dentistry. And I don't blame anybody because I have to blame myself if I do it. I can only explain it in engineering terms, what happened. And if you follow the engineering flow or path, you can get a lot better solutions. Let's look at some cases with Admira flow and extra with thermally injectable composites. Again, you don't have to heat it up if you don't want to. These are just before and afters. These are just things that you can do with the universal material if you understand your preparation, design, everything. Minimally invasive class 2s, pits you can flow, you can inject into that. This is all good. This is minimally invasive. You can actually push it a little bit. It opened this up and get into injection molding here with a universal material. If you look at a class 5, this is good. Especially class 5s are the most, you have the most stress coming down the shaft of the tooth. As you know, the strike point is the incisal cusp. And then when the strike hits through compressive forces or tensile forces, the stress goes through and spreads laterally into the DEJ, and that does the cross and then goes vertically down the root like a piling on a building, but the stress accumulates in the class 5 area where the enamel is the thinnest, and that's where the flexing occurs, and that's where you better understand the engineering principles. If we look at 2 failed composites, these are slot preparations. These are GB blocks. This is why they fail. This is why they don't work. You have to understand the radius bevel and how to leverage hydroxyapatite on a ratio of 2-to-1 or 3-to-1 to actually keep these teeth from falling apart. You can try in the material. The new Admira Fusion Extra is a pleasant material for universal shade. Now, when you get into engineering principles here, this is the vulnerable part right here. And when we start putting radius bevels, we want to create a shoreline that tapers, and actually the bigger the preparation, I'll actually take and put the radius all the way up here. That's why they call these root overlays at BioClear. Makes a lot of sense. A lot of docs say, hey, I'm going to put a little bevel. My bench instructor at dental said to put a millimeter bevel on here. Well, this is utter nonsense. From an engineering standpoint, you have to leverage this volume square area here to at least 1-to-1 or 2-to-1, which drives the radius all the way up here. Now, with adhesion here, you have to be very careful with a micro brush that you don't create debris. So I'll take the micro brush and paint the adhesion, then I'll take a dry bender brush and swipe the sulcus and get all the unintentional excess out of the sulcus, and then light cure it. Different ways I introduce flowable. I can caulk this window. I can put a flowable bead on the gingival level here, light cure it. I'll light cure up here on the superior margin, and then light cure a flowable caulk the window seam on all borders. Now I have an adhesive seal that I can backfill. Otherwise, you're subject to open margins, especially subgingival. When you bulk fill under 4 millimeters with a universal restorative material, this is what it looks like. I take the overhead light and put it on the patient's chin, and I can hand manipulate these before light curing, and then I have less cleanup on the end. You can see what my work looks like when I light cure it. This is post light cure. I don't have a lot of cleanup, which I encourage you to do or take my workshops. I'll certainly steer you into the path of enjoying the buildup and don't stress the cleanup. So I'll take my scout burr and I'll go through and verify all the integration, biointegration of the material, no delamination, no imperfections before I invest in polishing. Then take a very fine ultra flame burr and just marginate around here so I can make sure I am integrated adhesively around the tooth. Then I can invest with Voco at different hand pressure to either get particulate matter to break down or not break down. And this is what it looks like. It's breaking down. And I'm actually getting into a pre-luster right now. You can see it developing. This is going to be called the factory finish or the rock star finish. You can see this is post polishing here. I have no impingement on the tissue. Things are looking really good, and I've invested my radius bevel all the way up here. And this is the final result with universal materials today that could become true chameleons with engineering principles. I say that. Now, here I am 7 minutes early, right on time. I'm a taskmaster on time management. We covered a lot of ground, and I really want to tell you that if I was going to take a test to get credit here, I would say, what are patients looking for in the post-COVID environment? Well, they're looking for no chipping, no staining, single appointments. They're looking for all those things. And if I asked you which answer best describes thermal-assisted composites, well, if I said warming the composite increases the flow, the polymerization, and decreases the micro leakage, that would probably be a good answer to select. And if I asked you which answer describes the injection molding process, would I say it would be have a unique matrix that could contain the material? It starts with warming the material in the flowables. It is a slow, deliberate process, and it's best to be trained before you injection mold by somebody who can guide you into the injection molding process. It would be all of those answers. And if I said composite materials that don't have bis gamma, tegma, UDMA are more biocompatible, and they have less free radical monomers and less allergic reactions, would that be true? It would probably be true. And if I said, what would be the ideal temperature when using a composite warmer for the materials? Well, if you said 155 degrees Fahrenheit, I would think that would be a good answer. So these are some of the things that you can think about when you take the test. And I really want to thank everybody around the world for being part of the educational process post-COVID. And I want to thank Viva Learning. I'd like to thank all the manufacturers that sponsor these presentations, the new normal in distant education. Perhaps it is possible in the near future we can come together again into face-to-face and learn from each other and challenge each other and to raise the awareness. I want to thank the manufacturers that spend a lot of money on educating us and allow these to be these webinars and Zoom meetings and soon to be online workshops that are evolving now that I will be part of. And there'll be a privilege to do that. Remember, you don't have to heat composite. You have to learn how to use it. You have to learn the engineering forces that drive it. And if you get on that path, I've been doing this 43 years. I understand the big picture now. And why I wasn't successful for decades, I was doing GV black dentistry, and now I learn there's a better way. The modern method of injection molding with thermally liquefied materials that are healthy and safe. I want to thank you for listening to this presentation wherever you are. And let's go to some Q&A. What is the shrink wrap technique? Well, the shrink wrap technique, great question. The shrink wrap technique is where you have one layer, not layer upon layer, 2 millimeters. This, my instructor said in dental school, you add 2 millimeters and you cure it, and add the second layer and you triangulate it. And then the last layer is the final layer. And that's called patty cake. And shrink wrap is where you can put with an engineered preparation that has the proper adhesion, you're going to bulk fill with a thermoviscous material, and you're going to actually light cure it, which is shrink wrapping the material right onto the tooth. It's like putting a helmet on the tooth. Okay, good question. Okay, when doing the flowable bumper, actually, I learned in construction, caulk in the window is about as accurate as I can say. Prior to bulk filling, what flowable do you use? Is there any kind you can't use? Well, here's a good question. It comes down to material science. And the more highly filled the flowable is, and remember, if you put it in a composite warmer, the viscosity changes, and there's low flow, no flow flowables. I like to use a material that I can trust that is as highly filled, that doesn't have a lot of polymerization shrinkage, such as Admira Fusion Flow. And again, there's many good ones from the marketplace today. Be educated, be certain. Here's another good one. Do you ever micro etch the surface of enamel with aluminum oxide? Yes, you can. Now, you can't use pumice in a scaler and get rid of the biofilm. The micro etcher will get rid of the biofilm. You just don't want to destroy the hydroxyapatite. And with BioClear's blaster, you can have particulate. First, you must disclose with a disclosing solution where the biofilm resides, then you can blast it away. And obviously you don't want to do damage to the enamel, but that's going to be a very good question. These are excellent questions. What is the clear matrix used for the class 2? Okay, there's many good ones out there today. And Garrison, if you like metal matrices, Garrison has them. BioClear makes very good clear matrices. The fact is, the matrix is part of it. You have to know how to get good contacts and not flat contacts, pinpoint contacts. And I would say the clear matrices, you can look, BioClear has heavy duty matrices. They're very good. Clinician's Choice has very good matrices. Garrison has very good matrices, but learn the engineering principles to get up to that level. Do you ever use glue or desensitizing agents under the composite? Well, you can. G5 from Clinician's Choice. Hemoseal is another one. You can use desensitizing agents, but the best desensitizing agent is don't dry the dentin. Don't desiccate it because you're collapsing the collagen fibers. So Jeff, who asked the question, I said, yes, you can use them, but be mindful it is a piece of the puzzle and all the pieces must fit together. So with that in mind, I am right at the 1 hour mark. I want to thank Focal for sponsoring me tonight with great material with the new normal of dentistry with thermal viscous, and uh, I think they're positioning themselves with ISO packaging, with everything else. I think they're part of the new normal. There's many manufacturers that are becoming part of the new normal. And I want to thank you for my 17th Viva Learning webinar. There'll be more to come, and be part of the distant learning. And I wish you well wherever you are in the world. Great success. Go back and look at the literature now. That's your homework assignment. Don't go back to GB Black. I wish you well, and I want to thank Viva Learning and Dave Clark especially for being my mentor. And I'll look forward to seeing you hopefully in a classroom in the near future. Have a wonderful evening.